Hi everybody, it's Mr. Barbier, back with another video. Today's lesson is solving equations with fraction coefficients and roots. So this will be part 4 of the solving linear equation series. And this is a very important topic because students that I've taught over the years have had difficulty with fractions and with roots. So this lesson will go into detail how to solve linear equations with fraction coefficients and roots. Let's get right into it. So as you can see, we have our steps. First step, draw a line going down the equal sign, as always, okay? We always draw that line to help separate the equation into two sides. Step 2, if there are parentheses in the equation, use the distributive property to eliminate parentheses. That does not change. Step 3, look to combine like terms on the same side of the equal sign first using the money and debt method. Step 4, now combine like terms on opposite sides of the equal sign by doing the opposite operation of addition or subtraction. Remember, when you cross the line, you change the sign. Step 5, now solve for the variable by doing the opposite operation of multiplication or division. And then finally, step 6, which is optional, check your answer by plugging the value for the variable back into the equation. Okay, so notice our steps for solving linear equations have not changed. They are the same. So what makes working with fraction coefficients and roots different? Let's take a look at that. So I'm going to show you today 3 methods for solving equations with fraction coefficients. Now, those of you that know me very well, you know that I like to equip my students with multiple tools. Okay, I say all the time, I want you to be like a handyman who shows up to repair something with multiple tools. You don't just walk in with a wrench or with a hammer. You have several tools at your disposal. As a math student, I want you to be the same way. I want you to have multiple tools or multiple ways of solving a problem. So we're going to look at 3 methods. For equations with fraction coefficients, there are 3 methods. Method 1, multiply both sides by the denominator of the coefficient and then divide both sides by the numerator. Method 2, multiply both sides of the equation by the reciprocal. I'm going to explain later what that word means. Method 3, create a proportion and cross multiply. So those are 3 methods that we're going to look at, okay? Let's take a look at them right now. So here's my method 1. Method 1 again is to multiply by the denominator and then divide by the numerator. What does that look like? Well, let's follow the steps we are very familiar with. Let's draw that line going down the equal sign. Okay? Let's look to combine like terms. Now, first of all, do we see any like terms on the same side? Well, I see 2/5 x and I see positive 8. Are these 2 like terms? If you said no, because this has a variable and this doesn't, you are 100% correct. Now look at what's different with this equation than the equations we've done in the past. We have a coefficient that's a fraction. In other words, my coefficient is not 2x, it's 2/5 x. Okay? My coefficient is a fraction. The partner of the variable is a fraction, not a whole number. And ladies and gentlemen, when students see this, they just give up. They look at the equation, they say, you know what, I can't do it because I see a fraction. I'm not even going to try. And one thing I want you to know is do not give up at first sight. Okay, I always tell my students, do what you can do. And then when you get to the point when you're stuck, then you start to say to yourself, all right, let me see if I can figure a way to solve this problem. But at least take that first step. Okay, so if you ignore the 2/5 x for now, you know what the next step is. I know all of you do. What's that next step? If you said I'm going to combine like terms on opposite sides because I see the positive 8 and I see the positive 12 and I can combine them because they're both constant terms, you are correct. Now, tell me, do I subtract 8 on both sides or do I subtract 12 on both sides? Which would give me a balanced equation? If you told me we have to subtract 8, you are correct. So let's subtract 8 on both sides. And remember, ladies and gentlemen, we're doing subtraction because subtraction is the opposite of addition, right? So I need these two signs to be opposite. Otherwise, I cannot cancel these two 8s out, which is what I want to do. Whenever I combine like terms, I always want to cancel on one side and combine on the other side. That's always the case with combining like terms. So we cancel the 8s. We drop the 2/5 x. Right? Remember, drop it and move it over close to the line. I drop the equal sign. And then I combine this using money and debt. So if I have $12, but I owe somebody $8, what am I left with? Okay, 4. That's correct. Very good. Now here's the part where many of you would get stuck. Say, Mr. B, you know what? I see that fraction. I have no idea what to do. Let's do method 1, which says multiply by the denominator, then divide by the numerator. So remember, in algebra, we always do the same thing to both sides of the equation. What I do to one side, I must do to the other. So when I say multiply by the denominator, what I mean is the number on the bottom of the fraction, which is the 5, that's called the denominator, correct? The number on top is called the numerator. We're going to take the denominator and we're going to multiply both sides of the equation by 5. Like this. Watch me. I'm going to write 5 on the far left, and I'm going to put a multiplication dot. I'm going to use a dot this time, not an x, because I don't want to get confused with the variable x. So we're going to multiply the left side of the equation by 5, because 5 is the denominator. But remember, what I do to one side, I must do to the other side. So if I multiply the left side by 5, I must multiply the right side also by 5. So I'm going to put a dot here for multiplication and put the 5. Okay? What happens when I multiply a fraction by a whole number in which the whole number matches the denominator? Something very simple happens, ladies and gentlemen. What happens is this whole number 5 and this denominator 5, they cancel each other out. And I just take what's left over, which is the 2, I drop it down, and I drop the variable next to it, and I get 2x. Now, some of you are wondering right now, Mr. Barbier, I don't understand why they cancel out. How come they cancel out? Well, ladies and gentlemen, it's very simple. Let me show you. I'm going to write right here 5, okay, times 2/5. Let's not worry about the variable x just yet. Okay, let's not worry about that right now. How do I multiply a whole number by a fraction? Well, very simple. I take the whole number and I make it into a fraction by putting it over 1 times, and I just keep the fraction the same. Okay, and now I can do two things. I can either cross cancel or I can multiply straight across. Well, let's see what happens when I multiply straight across. 5 times 2 is 10, right? 1 times 5 is 5. And now 10 over 5, this is a fraction, but it's also a division expression because every fraction is really a division expression. So 10 divided by 5 is equal to 2. Isn't that what I got the first time just by canceling out the 2 5s? Yes, it's the exact same thing that I got. Now, one more thing I want to show you very quickly is what happens if we do this a different way. What happens if, for example, I cross cancel? Okay? Well, cross canceling means I look at the numerator of one fraction and the denominator of the other fraction. And I ask myself, do they have a common factor? Meaning, can a number divide into both of them evenly. Well, 5 can be divided by 5 evenly, right? And this can also be divided by 5 evenly. So if I divide 5 by 5, I get what? If you said 1, you're right. And look what happens. Cancel this 5 and I put a 1 on top. Again, 5 divided by 5 is still 1, so this becomes a 1. So this is why it's called cross-canceling. I cancel the old number and I write the new number. This can also be called cross-simplifying. Okay? I'm basically dividing this numerator and this denominator by a common factor. Okay? Which leaves me with, if I rewrite my new fractions, I now have 1 over 1 times 2 over 1. And now if I multiply straight across, 1 times 2 is 2, 1 times 1 is 1, and now again, 2 divided by 1 is still 2. Notice the exact same number we got on top. So, ladies and gentlemen, what I'm saying to you is this is, the long way to do it, so to speak, working everything out. But the shortcut is just to cancel the denominator 5 and the whole number 5, and I bring the 2 down, and I have 2x. So as you can see, there are shortcuts to math, but it's good to understand the reason for the shortcuts. Now, we multiply the left side by 5. The 5's cancel. We drop 2x. Multiply the right side by 5. 4 times 5 is what? If you said 20, you are correct. And now, ladies and gentlemen, we're very familiar with this part, aren't we? Right? We want to get the x alone. So we're going to divide both sides of the equation by the coefficient, also known as x's partner. Which number is x's partner? If you said 2, you are correct. So we divide both sides by 2. The 2 2's cancel. I drop x, and I drop the equal sign, and 20 divided by 2 is 10. Now, ladies and gentlemen, we can do the same problem, right, but using a different method, and this method is called multiplying by the reciprocal. Now, again, what's that word reciprocal mean? Reciprocal is a very important math vocabulary word. And what it means is, let's take a look at what reciprocals are all about. So, if I have a fraction, okay? If I have a fraction, let's say the fraction is 2/3. And I say to you, give me the reciprocal of this fraction, right? I want the reciprocal of this fraction. Reciprocal means that the numerator drops below the fraction bar and the denominator goes above the fraction bar. And essentially, I'm flipping this fraction, and now it becomes 3/2. Okay? Another word for flipping is inverting. Okay? You inverted the fraction. So that's what reciprocal means. It means taking a fraction and flipping it. The numerator becomes the denominator, and the denominator becomes the numerator. Now, what happens if I have a whole number, like 5? And I say to you, give me the reciprocal of 5. You might say, wait a minute, how do you flip a whole number? You can't flip it. Well, here's the deal. You have to make it into a fraction first. So we can make any whole number into a fraction. How? Somebody say it? Oh, you said put it over 1? Yeah, you're right. Okay, and now that it's a fraction, I can flip it, right? So denominator becomes the numerator. Okay, and numerator becomes the denominator. So 5 as the reciprocal of 5, let me say it that way. The reciprocal of 5 is simply 1/5. Okay, the reciprocal of 2/3 is 3/2. So that's what reciprocal means. So now getting back to this problem, we are multiplying by the reciprocal. But here's the thing, we're not going to do that just yet. We're going to do the same steps we did earlier first. So we still draw the line down the equal sign. Okay, I still subtract 8 from both sides. That doesn't change. The 8's cancel. Okay, I drop the 2/5 x. I drop the equal sign. If I have $12 but I owe someone $8, I'm left with 4. That still stays the same. And now this time, look what I'm going to do. We're going to go like this. We're going to multiply the left side by 5/2, which is the reciprocal of 2/5. Yes, I flipped it. And I put a multiplication dot right there. What I do to one side, I must do to the other side. So let me multiply this side also by 5/2. Be careful. A big mistake, a common mistake students make is that they'll put 5/2 on this side and put 2/5 on this side. No, be careful. You're multiplying both sides by the reciprocal. Okay? The coefficient flipped or inverted. Now, ladies and gentlemen, look what happens. You know how we canceled out those 5s over here? We said 5 cancels, 5 cancels. Well, look at this. Not only do I cancel out the 5s, but guess what? We can also cancel out those 2s because, again, they are on, one is a numerator, one is a denominator. I can cross-cancel them. So let's remember that when you are cross-canceling, you always cross-cancel a numerator and denominator, never a numerator and numerator and a denominator and a denominator. No, they have to be diagonal from each other. So the 5s cancel. Okay, in multiplication of fractions, I can always cross-cancel a numerator and denominator as long as they're the same, and I can cross-cancel these two 2's as well. And let's be clear about what's happening. When I cross-cancel, what's really happening is I'm dividing by a common factor, right? So I'm saying 5 divided by 5 is 1, 5 divided by 5 is 1. 2 divided by 2 is 1, 2 divided by 2 is 1. Now you're probably thinking, Mr. B, why aren't you writing the 1s? Well, because 1/1 times 1/1 just gives me 1, and 1x is the same thing as just x alone. Okay, drop the equal sign. Look at this, 4 times 5/2. How do I solve that? Well, once again, I have a whole number times a fraction. We did this already. I'm going to make the whole number into a fraction by putting it over 1. Okay, you can always do that whenever you multiply a whole number by a fraction. And now, ladies and gentlemen, I have a choice. I can either cross-cancel first and then multiply straight across, or I can multiply straight across. So you know what? Let's do it both ways. Let's multiply straight across first, and then later on we'll try cross-canceling. So 4 times 5 straight across. Remember, we don't cross-multiply when multiplying fractions. Okay, do not crisscross multiply. When you multiply fractions, you multiply straight across. So 4 times 5 is 20. 1 times 2 is 2. And let's remember, every fraction is really a division expression. So this is 20 divided by 2, which is 10. And again, x equals 10. Same exact answer that we got over here. Okay? Different method, same result. See that, ladies and gentlemen? Very simple. Okay? So we looked at method 1. We looked at method 2. Let's look at method 3. Method 3 says we create a proportion and cross-multiply. So the beginning steps are the same, right? We still draw that line going down the equal sign. We still combine like terms. So I see 8 and 12, right? I do the opposite operation. We did this already, but Let's do it again very quickly. These two 8's cancel. I drop 2/5 x, and I drop the equal sign, and I combine 12 and -8, and I get 4. Okay, let's stop there. Now, how do we create a proportion? Well, ladies and gentlemen, a proportion is something that's very simple. It's basically a ratio that equals another ratio. And ratios can be written in fraction form. So all we need is to have a fraction on the left and a fraction on the right. That's all we need. And we also need to do something with this variable because it's just kind of sitting in the middle beside the fraction. So what we're going to do is we are going to rewrite this variable term, right, with the fraction coefficient in another way. So instead of 2/5 with the x next to the fraction bar, I'm going to write 2x over 5. So ladies and gentlemen, what I'm telling you is something very simple. I'm telling you that 2/5 x and 2x over 5 are the same thing. They're equivalent to each other. Let me extend this line. Okay? They are equivalent. Now, some of you are wondering, wait, Mr. B, can you drop that x to the bottom and make it 2 over 5x? Absolutely not. Okay? Absolutely not. So if you want to write a variable term that has a fraction as a coefficient, you can write it two ways. You could write it this way, 2 over 5 with the x in the middle beside the fraction bar. Okay, again, not on the bottom where the 5 is, in the middle beside the fraction bar, or you could write it as 2x over 5, meaning put the x on top of the fraction bar next to the numerator. These two are equivalent. Okay, drop that equal sign. And again, I want to make 4, this whole number 4, into a fraction. How do I do it? Okay, someone just said put it over 1. Very good. And now, ladies and gentlemen, now that I have a ratio equaling another ratio, I can cross multiply, okay? Crisscross. And we're going to do it this way. We're going to say 2x times 1 and put the answer on the left, and then 5 times 4 and put the answer on the right. So someone tell me, what is 2x times 1? Someone just said 2x. Very good. I put that on the left side. Drop the equal sign. What is 5 times 4? Someone just said 20. I put that on the right side. And ladies and gentlemen, doesn't this look a little familiar, right? Didn't we just do this a couple of steps ago, a couple of methods ago? Yes, we did. We're now doing the last step, which is very easy. Divide both sides by 2, because 2 is the coefficient, right? 2 is the partner of the variable. The 2's cancel, and x equals 20 divided by 2 is 10. So notice we got the same answer 3 times, doing the problem 3 different ways. What I'm going to encourage you to do is I'm going to encourage you to practice all 3 ways so that you're familiar with all 3 ways. Okay? It's good to know how to do math more than one way. As a matter of fact, I always tell my students, if you solve a math problem one way and you're not certain of your answer, solve it another way and see if the answers match, and now you know you're right. Okay, let's now take a look at some practice problems. Here we go. So, let's look here. Directions. Solve for the variable in each equation. So, ladies and gentlemen, now's that time where I'm going to ask you to pause the video and do it yourself. So right now, hit pause. Try this problem by yourself. 2/3 x minus 6 equals 12. Come on, don't cheat. If you cheat, you're only cheating yourself, right? Pause that video. Try it. Okay, I'm going to assume you tried it. You're done. You've unpaused the video to see if you're correct. So let's see if you are correct. So we're going to draw that line going down the equal sign. All right. And then we're going to do what? You tell me what? You said add 6 on both sides. Okay. Very good. Draw that line across, right? These two 6s will cancel because the signs are different, but the term is the same. Very good. I drop the 2/3 x. I drop the equal sign. And now I have $12 and I have another $6. So altogether I have $18. Very good. Now, which method did you use? Okay, I think I heard someone say that they used method 1 for this problem. So let's try it. Method 1 says we're going to multiply both sides by the denominator first. So I'm going to multiply both sides of the equation. Let me put my little multiplication dots. And the denominator is what? 3. Okay. So 3 here, 3 here. Okay. And now, what's our little shortcut? We can just do what to the 2 3s on the left? You said cancel them out? Ah, okay. Thank you. And what do we do now on the left side? We drop 2x. Yeah? So we drop 2x like this. Okay, very good. Drop the equal sign. And now I have to work out 18 times 3, right? Remember, ladies and gentlemen, when in doubt, work it out. Don't rely on a calculator. Okay, just do it by hand. So 3 times 8 is what? So 24, okay. 3 times 1 is 3 plus 2, 5. All right. So now we have here 54. So 2x equals 54, right? And now the last step is to divide both sides by the coefficient, which is what? Which is 2, yes? Okay, these two 2's cancel. I drop the x, I drop the equal sign. Now some of you are saying, uh-oh, wait a minute, Mr. Barbier, 54 divided by 2, I can't do that in my head. Well, guess what? Neither can I. So we have to work it out, okay? When in doubt, work it out. Okay, let's do this. So, long division style. 2 goes into 5 how many times? Twice, yes? 2 times 2, 4. 5 minus 4 is 1. Very good. Check. Is 1 less than 2? Yes, it is, because this has to be less than that. Bring down the 4. And now 2 goes into 14. 7 times. Very good. 7 times 2 is 14. 14 minus 14 is 0. Okay, so that means that x, ladies and gentlemen, equals 27. There it is. Very simple. Okay, very simple. Guess what? We'll look at one more problem, all right? Let me see here. I see problem number 2. I see problem number 3. Guess what? Let's look at problem number 4, all right? I know some of you are looking at that and you're saying, wait a minute, that looks scary. It's not. It's not, okay? And I also want you to challenge yourself, ladies and gentlemen. Always challenge yourself. Don't run scared from a problem. Embrace a problem, okay? Embrace a challenge. So what do we know to do whenever we see a linear equation with parentheses? Okay, someone just said, Mr. Barbier, you need to do the distributive property. You are correct. So draw my beautiful arrows, but wait a minute, don't forget, draw my line first, okay? Don't forget my beautiful line. Yes. Now let's draw those beautiful arrows. From the 2 to 3 over 10x, and from the 2 to the negative 5, right? And don't forget that multiplication sign right here. Okay, so you might be saying, Mr. Barbier, how do I multiply 2 times 3 over 10x? Well, guess what? We already know how to do it, don't we? Don't we take the whole number and put it over 1 and then just multiply straight across? Yeah. Guys, can I tell you something? Shortcut. Don't worry about writing that out. If I know that I'm going to put 2 over 1 and multiply straight across, well, then I'm multiplying a numerator 2 times a numerator 3, correct? Without even me having to write it out. Now, if you do need to write it out, okay? Let me just be very clear about that. If you feel more comfortable writing it out, write it out, okay? But what I'm telling you is if I'm multiplying a whole number by a fraction, all I need to do is multiply that whole number by the numerator. So 2 times 3 is how much? You said 6, you are correct. and just keep the denominator the same. All right? So let me say that again. Do not multiply 2 by 3 and by 10. No. Okay? Only by the numerator. Keep the denominator the same. Okay? And we also keep the x the same. Now, don't forget, ladies and gentlemen, don't bring down -5. That happens a lot. Students make that common mistake very often. We multiply with the 2 twice. So 2 times 3/10 x is 6/10 x. 2 times -5 is what? If you said -10, you are correct. I dropped the equal sign and I dropped the -7. Okay? What do you know to do now? Someone just said combine like terms on opposite sides. That is correct. So we're going to add 10 to both sides. Okay, these two 10s will what? They cancel out. I drop the 6 over 10 x equals, now let's use money and debt. You owe someone 7, but you have 10. So after you pay them the 7, what are you left with in your pocket? If you said $3, you are correct. And now, ladies and gentlemen, let's use a different method, okay? We already did method number 1. Let's use either method 2 or method 3 for this problem. So which one do you pick? Okay, I think I heard someone say, Mr. Barbier, I want to try the proportion method, method 3. Okay, let's try it. So what we're going to do is we are going to rewrite this. Let me extend my line. We're going to rewrite this this problem at this point of the problem as 6x over 10. Remember I said we can take that x and move it to the top, never the bottom, equals, and make 3 into a fraction. How do I do that? Someone just said put 3 over 1. Very good. And now what do? Now that I have a proportion in front of me. Okay, yes, very good. We cross multiply. Okay, crisscross. Okay, so help me to do that. Help me do that. 6x times 1 is what? Someone just said 6x. Okay. 10 times 3 is what? Someone just said 30. Put the 30 right there. Drop the equal sign. And what do I do now? Okay, someone just said divide both sides by 6 because 6 is the coefficient. The 2 6's cancel. And now let me just slide over to the right because I have no more room. X equals what, someone? Say it before I say it. Okay, someone just said 5. Very good. And that is the answer. And ladies and gentlemen, let me just be clear about something. It doesn't matter which of the 3 methods you use. Trust me, the answer will be the same. It'll still be the same answer, x equals 5. Okay, so you're going to try problem 2. Okay, write it down. And problem 3 by yourself. Okay, try that right now on scrap paper, on loose leaf. Okay, work it out and see how you do. Okay, so we're going to stop the video at this point. Ladies and gentlemen, one more thing I want to say real quick is you do have homework. Let's not forget, because practice makes perfect. 2 problems is not enough. Definitely not enough. So you're going to do these 4 problems as well. Okay, you're going to do these 4 problems as well, in addition to those 2 problems. All right, so work them out, do your best, keep practicing, and I'll see you in the next video. Take care.